Here we are looking at example 3 from our 3-3 set of notes. We're asked to graph this system of linear inequalities. Let's go ahead and start off by this graphing this first one. We'll label him as our green linear inequality. And we notice that he's in standard form. So from that we can go ahead and construct our box. And throwing in 0, 0 on that main diagonal and x and y above him. Now if 0 is x, essentially this piece is gone. So 2 times what would give us 8, 4 would do that. Now if 0 is y, essentially this piece is gone, 4 times what gives us 8, 2 would do that. And in doing so, from our box, we've actually created our 2 points, our x and y intercept there. This would be our y-intercept, here would be our x-intercept. So let's go ahead and plot those now. We have 0, 4, which is right here, and 2, 0, which is right there. Now when we want to connect these 2 points, we first have to determine, do we have a solid or a dotted line? Well, just looking at our inequality, we notice that we have a bar underneath, which indicates a solid line. And as a result, connecting these 2 points, we have a solid line. We should see something like that. Now we have to go ahead and test a point to see which region do we need to shade, below or above our graph. Now, again, 0, 0, the origin is a very, very nice test point. It is off the line, so we can use it. Throwing our 0, 0 in is 4 times 0 plus 2 times 0, larger than or equal to 8. On the left side, you would just end up with 0. Is that larger than or equal to 8? The answer is no, it is not. So this was false. We tried 0, 0, did not work on the graph. That means none of these other points below the line would work either, which means we would have to shade to the right or above, kind of looks like above, of our line. Now going ahead and doing the bottom one. Right now we see that he's in y equals mx plus b type form. So we're going to go ahead and graph that in terms of that y equals mx plus b. Starting out with our y-intercept, we have a point at -3, which is right here. And we have a slope of -2, so down 2 over 1, down 2 over 1, or to the up 2 to the left 1, up to the left 1. Now determining if this is a solid or a dotted line, we notice that there's no bar underneath, and as a result, this would be a dotted line between these points. So you would see something like this. Now we also have to test a point to see which region to shade. So testing 0, 0, again, nice test point, is 0 less than -2 times 0 minus 3. Well, we still have 0 on the left side. On the right, we have -2 times 0, that's just 0 minus 3. So is 0 less than -3? Unfortunately, the answer to that is no. It is not. 0 is larger than -3. So we tried this test point, did not work. That means that we would have to shade the other way. So for example 3, that would be our graph. Notice that there is no overlap at all, and that can happen depending on your inequalities. The reason for that is, in fact, it looks like they have parallel slopes. These 2 lines are going to be parallel with one another. In fact, if you put this into y equals mx plus b, you would see that -2 slope. So there will actually be no intersection here. All right. So again, though, that is example 3 from our 3.3 set of notes.